Hi friends, this video we are going to see what is the linear differential equation, that is homogeneous and non-homogeneous differential equation. Second, what is the linear combination of the function, and what is the superposition principle. And then whenever the differential equation their solutions are linear dependent and dependent, how to find those things only we are going to see. First we start with the linear differential equation. Suppose consider a linear differential equation is nth order differential equation is written as a naught of x y nth prime plus a1 of x y n minus 1 times derivative and so on, plus a n of x times y equal to some b of x, where y of x is the y of x is the independent, is the dependent variable. Yes, x is the x is the dependent variable. Sorry, dependent variable. Independent variable. So only one independent variable. So that's why it's a ODE on a differential equation, and we have to assume that a naught of x is not equal to 0. This is most important. That is a naught of x is not equal to 0. Okay. So then this is the nth order differential equation. Next, if v of x equal to 0, then so suppose I assume that this is the equation number 1. 1 is called a homogeneous equation. Homogeneous nth order linear differential equation. Otherwise, that is otherwise otherwise that is p of x not equal to 0, then equation 1 is called a non-homogeneous homogeneous nth order linear differential equation. Okay, suppose this guy is 0, we called as a linear differential equation. This guy is not equal to 0, we called as a non-linear differential equation. Example, y double prime plus 4y prime plus 3 times y equal to x square times exponential of x. So this is second order linear differential equation. So right hand side is b of x is here. Here b of x is x square times exponential of x. It is not equal to 0. So this equation, say example of non-homogeneous linear second order equation. Correct? Differential equation. Since because the highest order derivative is here 2. Second example, we see y triple prime plus 3y prime plus y equal to sin x. This is also, this is non-homogeneous linear third order differential equation. Correct? Suppose the same equation, suppose I write it as y triple prime plus 3y prime plus y equal to 0, then we call it as a homogeneous linear third order differential equation. Correct? So this is for the example for homogeneous and non-homogeneous. So one more example we see, that is for variable coefficients. So 1 minus x square y double prime minus 2x y prime plus 20 times y equal to 0. So please assume that x equal to plus or minus 1, this guy is 0. So whenever the differential equation, so x equal to plus or minus 1, so this implies a naught of x, from our definition it's become 0. So it's so our domain does not contain those points, that only we consider. So this is homogeneous linear second order differential equation. So in this a naught of is not equal to 0 I required. So whenever the interval this point is not included, then only this differential equation is second order. Otherwise it's not a second order differential equation. So please be careful. So those point is technically we call it as a singular points. So that is x comma 1 is called as a singular points. So it's out of the scope of this video. So we didn't give too much information about the singular equation. Okay, fine. Second is, now we are going to study what is the linear combination of the function. Let f1 of x, f2 of x, and so on, f n of x, okay, be a n functions. then C1 F1 of x plus C2 F2 of x and so on Cn Fn of x, where Ci's are constants. So then this term is called a linear combination of given function. Okay, so now see some example. Suppose I have the function x square x cube. So this is the linear combination is, suppose I take it as some f of x equal to c1 x plus c2 times x square plus c3 times x cube. This is the linear combination of the given function. So one more example. Suppose I give the function is sin x. So this is example 1. So example 2 is sin x. Another is cosine x. Then your linear combination is f of x equal to c1 times sin x plus c2 times cos x. Why we require uh, the linear combination? Because next we are going to see what is the superposition principle. Is one of the very important results, because this results only gives the your whenever nth order differential equations, linear homogeneous differential equations, suppose you have some solution, the linear combination also again a solution. This is only gives. Now we see what is the superposition principle. Some people they call it as a linearity principle. Superposition principle or linearity principle. If the result is very clear, if y1 y2 and so on ym are solutions of the nth order linear homogeneous equation. So we see what is the nth order linear homogeneous equation is. We give the equation number 1 if b of x is 0. That is our assumption. Okay, this linear nth order homogeneous differential equation, then linear, then a linear, so any linear combination, okay, not a particular, then a linear combination of the solution is also a solution of the that particular differential, the linear nth order differential equation. Linear differential equation. Okay. So now I give the some remark. So remark is, because please be careful, this result is only true for homogeneous linear differential equation. The superposition principle does not valid for non-homogeneous or a nonlinear equation. Nonlinear differential equation. So please be careful. Okay. So principle work for homogeneous linear differential equation only. Okay. Next is linearly dependent or independent. So sorry, I forget to see some example. Correct? Okay. Now suppose I will take consider example. We see one example. The law 1 by 2 x and the exponential of 3 by 2 x is the solution of second order differential equation. Solution of y double prime, sorry, 4 times y double prime minus 8y prime plus 3y equal to 0. So the linear combination also again is solution. Let's first we'll check that it's a solution of this differential equation. Correct? Uh, Suppose the linear combination is, suppose my y equal to c1 times exponential of 1 by 2 times x plus c2 times exponential of 3 by 2 times x. Okay. Now what is the y prime? Y prime is 1 by 2 c1 exponential of 1 by 2 times x plus 3 by 2 times c2 exponential of 3 by 2 times x. Correct? What is the y double prime? Y double prime is 1 by 4 c1 exponential of 1 by 2 times x plus 3 by 4 c2 exponential of 3 by 2 times x. Now we are going to add. Correct? So for the my 4y double prime plus, so here double time if you are getting 9 by 4, correct? Yes, 4 times y double prime minus 8y prime plus 3 times y equal to 0. Now you apply 4 times 1 by 4 c1 times exponential of 1 by 2 times x plus 9 by 4 c2 times exponential of 3 by 2 times x minus 8 times 1 by 2 c1 exponential of 1 by 2 times x plus 3 by 2 times c2 exponential of 3 by 2 times x plus 3 times c1 exponential of 1 by 2 times x plus c2 times exponential of 3 by 2 x. Correct? Now if you look, so this 4 is multiplied, it's become 1. Here 4, so 3. So these automatically will cancel. So 9 plus 2, 9 minus 3, 9. So we will get, so we will take it. So c1 exponential of 1 by 2x. So this guy is minus 4 times c1 exponential of 1 by 2x. From here plus 3 times c1 exponential of 1 by 2x. If you look the coefficients, it's become 0 plus this guy is 9 times c2 exponential of 3 by 2x, and the here is minus 12. Correct? 12 times c2 of exponential of 3 by 2 times x plus 3 times c2 exponential of 3 by 2 x. So if you are applying this guy, it's 1 plus 3 is 4, 4 minus 1 4. So it automatically satisfies the given equation. This is the superposition principle says. So the length of the video. So next video we see what is the linear dependent, what is the linear independent of a given differential equation. Thank you for watching this video.